Okay, sum and differences. Here are the identities that we talked about before, the sum identities and the difference identities for sine, cosine, and tangent. And you should have been working with them from before, but here's another way that you could use them. So we are going to use, in this case, they're asking us to use the cosine, the sum identities for cosine, and they're giving us some information. They're giving us the sine of one angle alpha and another angle beta. And they're telling us, we know from chapter 6 that sine is going to be opposite over hypotenuse and cosine is going to be adjacent over hypotenuse. And they're telling us that alpha lies in quadrant 2 and beta lies in quadrant 4. So if that is the case, and that makes sense because sine is positive in quadrant 2 and it's a positive trig ratio, and beta is for cosine, and cosine is in quadrant 4, and therefore cosine is also positive in quadrant 4. So that all matches up, and then we're good. Okay, so what we're going to do first, I'm going to take the green one as going to be alpha, that is in quadrant 2, and I'm going to do what I did before. Oops. Um, so we're going to take this and we're going to make that. Okay. And so then this one here is going to be my alpha. So here's going to be my alpha. And so we know that it's going to be opposite over hypotenuse. So we do this. This is going to be 2. And then the hypotenuse is 3. Remember, the hypotenuse is always going to be positive. This one here, because it's a positive y value, that's going to be positive. This is a negative x value. So whatever goes here is going to be negative. So how do I find that? Well, I know that this is a right triangle. So we do, when we do this, we do 2 squared plus, and I'm just gonna call that x squared is equal to 3 squared. And so I get x squared is equal to 9 minus 4. So x is going to be plus or minus the square root of 5. But I know that it's a positive because it's the length, so it's going to be positive square root of 5. But because it's negative, in the negative quadrant, it's the negative square root of 5. Okay, so I know the right triangle for that. And then I'm going to do the same thing for this one here. Now, this one here is going to lie in quadrant 4. And so I'm going to remember it's always off the x-axis, a right triangle. Then this one here is going to be my beta. And then we're going to do opposite over hypotenuse. And then we're going to do the same thing that we did over here. And so now it's going to be x squared is equal to 3 squared minus 1 squared. And so I get x squared is equal to 8. So x is going to be the square root of 8 plus or minus. This is the positive x-axis, so it's the square root of 8 right there. And that's how we solve that there. Okay, so now that we have that information, now I could actually use this, the cosine of alpha plus beta, the sum identities. And so what we're going to do is we're going to say the cosine of alpha plus beta. We're going to use this identity. And if you notice, there's a negative and a positive. They're opposite signs for cosine. And so we're going to do that to be cosine of x, cosine, oops, I was just doing it up there, but this would be cosine of alpha, cosine of beta, and then it's going to be minus sine of alpha, and then sine of beta. And so you're already given the sine of alpha and the cosine of beta, so you could just actually fill that in. So when you fill that in, the cosine of beta, I'm going to do that in green. So the sine of alpha is going to be minus 2/3. And this one here, the cosine of beta is going to be 1/3. And then the other two you actually find using the triangle there. So this is an alpha, so the cosine is going to be adjacent over hypotenuse. So that one's going to be negative square root of 5 over 3. And this is multiplication, and this is also multiplication. And then we do the sine of beta, which is going to be opposite of our hypotenuse. So it's going to be 1/3 as well there. And so that's how you do it. And then you find your answer here, and it's going to be negative square root of 5 over 9 minus 2 over 9. And so your final answer is going to be negative square root of 5 minus 2 over 9. And that's what the angle equals to. So when you do that, that's what it's going to be. That's what it adds up to. Very good. All right. So how do I use identities, these identities to prove um, this identity, or this, we're trying to prove that the left side equals to the right side. So how do I do that? So I'm going to take um, information from here. And so I could either do on the left side or the right side. I'm going to do the right side. And so it's going to be a little bit long, but then it should cancel out to be this information right here. So I'm not going to touch it. This is a proof. So I'm going to work on the left, make it look like the right. So we're going to start here. We're going to do the cosine of A, cosine of B, because we're doing this part. And then what we're going to do is, because this is positive, this is going to be negative, and it's going to be the sine of A, the sine of B. And so the minus stays, so that's this minus right there. And then now we're going to do this other part right here. So now we're doing this part. So we're going to do the cosine, and then this is the whole thing. So it's the cosine of A, the sine, I'm sorry, the cosine of B. And now it's a minus, so this is going to be a plus, and it's going to be the sine of A, the sine of B. And equals. So this is all on the left side. Notice this blue is going to be here and it's going to distribute there. That's a common mistake. People only give it to this term and not to the last term. Okay, so now we just get to combine on there. And so what happens? So here I have the cosine of A and the cosine of B. So I know that this here is going to be minus. So what happens here is that these two are going to cancel. And these two are the same, so it's going to be two of them. So it's going to be 2 sine of A, sine of B is going to equal to negative 2 sine of A, sine of B, which is what the left side. So the left side equals to the right side. Okay, and then we're going to do one more. Okay, so now on this one here, we're going to be able to look at it and then figure out which one do I want to do. Do I want to do the left side or do I want to do the right side? And we're going to do this time, we're going to do it on the left, on the right instead of the left. And mainly it's because this has the identity of the expansion on there. So we're going to have 2, and then it's going to be parentheses cosine of x, cosine of pi over 6. And then it's plus, so this one's going to be minus sine of x, sine of pi over 6. So when we do this, you do the left-hand rule, and it's going to be the cosine of pi over 6, which is 30 degrees. So it's going to be square root of 3 over 2, and it's being multiplied. And this one here is going to be the sine, and then of x times 1/2. And then the 2 gets distributed to both of them, and this is a coefficient, so it moves to the front. And notice how this is over 1 because it's a fraction times a fraction. So what you actually do get is you're going to get the square root of 3 cosine of x over 2, because numerator to numerator, denominator to denominator, and then you're going to distribute that, so you're going to get a 2 there. And then same thing here, you're going to get minus, and it's going to be sine of x over 2, and then you distribute that 2 because this is over 1, so it's numerator to numerator, and so these are going to cancel, and you're left with the square root of 3 cosine of x minus sine of x. And then there should be, so that's a minus, and that should be a plus. And so I think this one here has a mistake, and that should be a minus, and then that should be on there because this should, it's the opposite of it. So it should be a minus there. Okay, very good. So it would be the square root of 3 cosine of x, and that's a typo. And that's what it should be. Okay, very good.